This question will come up on your MCAT.
Which of the following is the correct ground state electron configuration of iron 3+? So to answer this question, let's first of all figure out the ground state configuration of neutral iron, okay? Because here they're asking us about the iron cation. So one of the ways that you can do this, and I've included a periodic table here, is we got to find iron, and we notice that it's in period 4, right? This is period 4. This is iron. And so what we can do here is we can use the noble gas notation, where we're going to say that, iron and anything in period 4, first of all, has the electron configuration of the noble gas in the previous period, or one period up, which is argon, right? So we're going to start with argon. And then remember that since we're in period 4, we have access basically to the 4th energy level. So n is equal to 4. And so the lowest energy orbital that can be filled with electrons at this energy level, right, is going to be the 4s orbital initially. And so for potassium, you would put 1 electron into that 4s orbital. And I'm actually going to draw it like this as well. So we're going to have the energy diagram here, okay, where basically, we're going to have argon. We're starting with that baseline state. And then we're going to have the 4s orbital here, which when it comes to filling electrons, the electrons will go into the 4s orbital first. So for potassium, and this is how I like to do it, once I establish like which orbital we're going to be starting with, or rather which shell we're going to be starting with, we're going to just go left to right in the period. So potassium, you put 1 electron into 4s. For calcium, you're going to put another electron into 4s. And then we're going to get into these elements. So these are actually all transition metals. Now, this is actually going to be the first period, period 4, where you have access to d orbitals. However, those d orbitals are not 4d orbitals, they're actually 3d orbitals. And remember for d orbitals, the d shell, there's going to be 5 of the orbitals. Okay, so there's going to be 5 of them here. So this is going to be 3d. And remember that this is like with this electron configuration diagram, this is based on energy level. So the higher you go, the higher energy you are. Now the rule is that when you're filling the orbitals, right, you fill the 4s subshell first, and then you start filling the 3d subshell. And so we're just going to go scandium onwards, left to right. So we're going to have an electron in 3d. But remember that the way we're going to fill these orbitals is we're going to put 1 electron in each orbital at a time before we start pairing them, because that's actually energetically favorable. If you pair them, there's more electron repulsion that way. So we're going to distribute them through all the available orbitals in that shell. Okay, so we're going to go 1 electron for this, then another electron for this, then for this, then for chromium, right? And then manganese. And then we get to iron. Remember that we're trying to do this for the neutral iron, okay? So we have to put a 6 electron into the 3d shell, so now we're going to actually start pairing them. And this is going to be for neutral iron. Now, the question is asking us to find the ground state or lowest energy configuration for iron when it's lost 3 electrons, right? Which is iron 3+. So we have to remove electrons from the neutral iron. We need to remove 3 of them. And where do we remove them from? Well, the rule here is even though the 4s shell is filled first when you're filling the shells, okay? When the 4s orbital is actually filled with electrons, it actually becomes higher energy than the 3d orbitals. That's just something you have to remember. So as it turns out, when we start removing electrons, we're first going to remove electrons from the 4s. We're going to remove 1, that would be iron 1+, then 2, that would be iron 2+. Okay, and then we need 1 more. And so of these 3d electrons, we're going to remove the electron from the orbital that has 2 of them to minimize repulsion. Okay, and so this will be the electron configuration for iron 3+, which if we write it will simply be argon. Okay, there's nothing in the 4s, so we're not going to have that anymore. And then there is 5 in the 3d, so it would be 3d5, and this is going to be iron 3+. Okay, so that's how you would do it.